This video talks about how to write a program for Project-01. So the last video was an overview that showed you generally what was going to happen. Here it is happening right in front of you. So here's the part. Again, our goal is to inspect balloons number 1, 2, and 3. So we're going to inspect the OD, the distance from the center of the part to the flat on the front, and then the ID, and that's it. But to do that, we do have to perform an alignment as well, along with all the other steps that are required just to run the CMM software. So switching over to Part Manager, we'll start a new part. We'll name this Project-01, and so we'll launch this into Learn mode. This is just warning us that we're in offline mode. Of course, we're in offline mode. We're not hooked up to a CMM. I noticed that the window positions are a little bit different than the default at the school. That's because I played around with that on my home computer, so sorry about that. The main windows are the same. We have list of results, graphics of elements, and then the part program list here. So this part program list is going to be all the list of steps that the CMM is following to get the results. The results will be recorded over here and shown to you graphically down here. Alright, so Learn mode is open. That allows us to see what our CMM looks like. Notice that we can't enter into Learn mode or repeat mode because it's already open, but we can launch our CAT 1000. Alright, so I'm going to import a single model. We'll grab the model with the fixture on it and say open and OK. And we can't see anything because the machine is in the way. So I will come up to this toggle, show actual machine position, turn it off, and we can see that the part did come in the correct orientation. We just want to make sure that the part's not rotated off 90 degrees relative to the coordinate system shown here or something like that. So we are in the correct position relative to the origin, but the origin is not in the correct spot on the machine. So we'll come up here to coordinate system and part alignment. Notice that it drops it roughly in the correct position on the machine. If you want to, you can move just this X, Y, and Z position here. Really, more often than not, it will drop it roughly centered, and you don't have to do this. I'll show you how to do this just so you know. Sometimes you have big enough parts that they won't really fit in the machine if you don't move them. Basically, we'll move this to the position that we want, and this is going to create coordinate system number 1, and we simply say OK. Alright, now switching back over to Learn mode, we have created coordinate system 1, so now we can do our subprogram to do our start block. Notice that as part of the start block, it is going to load our coordinate system. We'll say no to go into offline mode. We'll say OK, CNC mode's going on. This is a warning about when you prove the program out for the first time. We'll say OK to that for now. Our next move is we have to link up the coordinate system that we loaded here and the coordinate system that we are actively using in CAT 1000 here. So to link the two of these up, we will say coordinate system and set relation to CAD coordinate system. We always accept the default here, that's the middle button, and say OK. Notice that the subprogram collapses itself, so that way we only see the summary level view. Our next move here is to start our our automatic alignment. All right. It's going to be easiest to go to an isometric view here. And for our automatic alignment, we're going to do a plane, circle, line alignment. Details on this were provided in the overview. I'm just going to show you the steps on how to do that here. So we'll say element plane grid. For our complete edge, we'll click right around here. Notice that defaults to giving us 4 points. It looks like those 4 points might be a little bit close to where the clamp could rotate. So for start angle, let's say we want to start right about here. And for end angle, it looks like it's not giving me an option. I'll turn off full circle, and now it gives me the option for end angle. I'll click on this dot to reselect that, and I'll put the end angle somewhere over here. Alright, the diameter looks like it's still a bit large. Let's decrease the size of that diameter a little bit, and there you can see we have 4 points that are, maybe we'll change the start angle just a little bit more to make sure we clear that clamp, and 4 points that are evenly distributed around the model, except for where the clamp could potentially rotate. We'll name this feature Datum A. Call it Datum A because if we look at the print, It says clearly right here that the top surface should be datum A. All right, we'll also do a circular move here as well, in between points. I say OK. All of that information is exported over to Learn mode. So next we'll go coordinate system, align base plane. We are going to align to datum A in the XY plane, and we'll create origin in element. We'll say cancel to the clearance height. We already have a clearance height of 1 inch set. Now this next point is going to be somewhat tricky. We actually have to create 2 separate circles and then connect them after the fact if we want to use CAT 1000. If we were programming in CNC mode, then we could build out 2 different pieces of this circle individually. Here it's going to be easiest, for the sake of this video, to do an element circle. You know what we could do here? We could come in here and turn off our clearance plane. So we'll go machine, clearance height, and we will turn that off. See, it's turned off now. And that gives us access to collision check, and maybe we'll get lucky and this will work here. We'll touch a circle. For our complete edge here, we will select something right around here, start angle right around here, end angle on the opposite edge of the part. Measurement height is set to about minus 80 thousandths. That looks about right. Minus 100 thousandths if we want to be a little bit cleaner with our numbers. And let's do a recalculate and see what we get. Yeah, so it looks like collision check is not smart enough to jump over this particular feature. I guess we'll have to do it the other way. When that collision check works, it is a beautiful thing. When it doesn't work, oh, it's just very frustrating. So collision check is not going to work in this case. So we'll close out of this. We will get rid of that clearance height off, and we will build out this feature as 2 separate steps. All right, so we'll start off with a circle type feature. We'll touch a circle on this complete edge. We'll start here. We are going to have to turn off full circle measurement, and the end point of this arc will be right around here. For our measurement height, it looks like that got something pretty close to 100 thousandths. We can type in minus 100 thousandths here if we prefer and recalculate. And looks like we have to reselect our end angle here. There we go, much better. And we really only want to touch 2 points here. We'll call this datum B, and because we're doing this with 2 separate features, I'll put -01 here. And we'll move circularly to get from point to point. Oh, forgot about that. We need a minimum of 3 points for a circle. And it looks like, yeah, those points should give us just enough clearance to get around that clamp. And I will say OK. So that was the first part of the feature, but now we have to jump up and over to get to the second half of our circle. Keep in mind we have clearance plane on, so it will do that automatically. We'll go to a back view here. So we're now looking at the back of the part, and we'll select another circle here. That'll be our complete edge. Our start point will be here. End point will be, oh, rotation function in this software leaves something to be desired here. Yeah, it looks like that end angle is a little close to the end of the part. We'll end that 50 thousandths away from the edge of the part or so. And we'll name this datum B-02. Of course, if we want to see how it's getting over to this feature, let's go to an isometric and flip backwards. It looks like this probe is going to jump up and over the feature. If we'd like to see more details, we can modify the speed that this simulates at and then hit play to watch the simulation. Looks like we should have plenty of clearance. It does look like we're getting a little close to this pin here. We'll just have to make sure that that pin is threaded down into the plate when we run this part for real. So we say OK here, everything looks good, and then we switch back over to Learn mode to see what we got. So we have datum B01 and 02. It's really just 2 halves of the same circle. In Learn mode, we will create a circle, and we will do a connection element, and we'll name that connection element datum B. Connected. will say OK. And we'll grab datum B, parts 1 and 2. We will project them onto our XY plane, use measured points, and say OK. So you can see in the graphics screen here, datum B has been created. So now we can go back into our alignment and say create origin. So we'll create the origin to datum B connected. Part 1 and part 2 only tell part of the story each. We want the connected version so we get the average of all of those points rather than just the left side or just the right side. We're setting our x-axis and y-axis to 0 here, and then we can hit cancel to ignore our clearance plane. All right, back in CAT 1000, we go to an isometric view. You can see that those circles have now been drawn here as a complete circle. And we will come in and create an element line. We will name this datum C. How do I know it's datum C? Well, it says datum C right here on the print, and I skipped over this, but it also tells us that datum B should be that outer diameter as we just measured as well. All right, so we will create a line for our complete edge. We'll click right here. We'll move the start point in a little, end point in a little. Looks like we may get kind of close to that with the probe, so we'll do a quick simulation up here. Yeah, it looks like we have just enough clearance. Again, when we set this up on the real machine, we'll make sure that these set screws here are threaded into the plate a little bit deeper. All right, this is defaulting to datum C. All the other defaults are good, so we say OK. Now the important thing to remember for an alignment is switched back over to learn mode here so we can see the list of steps. You're going to touch a feature, align to it. Touch a feature. Now in this case, we broke the circle up into 3 separate features so that we could jump over the clamp. But that is touching the feature, and then we align to it. The next step is to touch another feature, and of course we have an alignment command coming right after that as well. The alignment command is align axis parallel to axis. So we'll select the XY plane, x-axis, origin in element, sets our y-axis 0 to that line, and we'll say OK, and then cancel to the clearance height. Now I notice I actually made a mistake here. With that last command, we don't actually want to set the y-axis 0 to the front of that element, because if we look at our isometric view in learn mode here, we see that our coordinate system is now set to the front of the part. So that's kind of a force of habit thing that I did there. We are used to saying origin and element, but in CAT 1000 we can also see there was our original coordinate system, and we have now moved the coordinate system to here. So I will delete that last command in learn mode, and I'll put that command back in. We are saying align axis parallel to axis. It is very important that you uncheck origin on axis for this and say OK. All right. Looks much better here. We see in learn mode our origin is still at the center of the part. Looking at CAT 1000, we see that the origin is still at the center of the part here. That's good. So the alignment is now complete.